Okay, so let's say, for example, determine if the series from n equals 1 to infinity of 6n plus natural log of n divided by 6n to the nth power, and that also to the nth power, converge or diverge. Okay, so we can use the root test to get rid of those exponents. So you have the limit of the nth root of the absolute value of a sub n as n approaches infinity. That will give us the limit as n approaches infinity of the nth root of 6n plus natural log of n to the nth power over 6n to the nth power, which once again we can just combine those two. The limit as n approaches infinity of the nth root of 6n plus natural log of n divided by 6n to the nth power. Okay, where these two, your index and your exponent, cancels out. So that's equal to the limit of 6n plus natural log of n. Actually, that should be an absolute value, but I'm not going to worry about that. Over 6n. Okay. And actually, if you did plug this in, you get infinity over infinity. Which means you use L'Hopital's rule. Okay, so that's going to equal the limit as n approaches infinity. Probably should have made that a little lower, but I can just move that up. Okay, so if we use L'Hopital's rule, derivative of 6n is just 6. Derivative of natural log of n is 1 over n. And derivative of 6n is just 6. Okay, so that equals the limit. Actually, that as it increases, that approaches 0. So we really don't need another line because 6 divided by 6 is just 1. So it's inconclusive. Okay, so you just use another test. So actually, on this example, they just gave the converges absolutely, diverges, or it's not enough information. So for this one, it's just not enough information. It was one of those multiple choice tests. Multiple choice questions. Okay. Oh, not a problem. All right, so for this one, probably the best one to use wouldn't be the... Nope, that would be too long. And for that one, probably wouldn't want to use the ratio test. That would just be messy. So that one, probably the test for divergence. Okay, so that would give us, we just have to find if the limit does not equal 0. So actually we figured out the limit as n approaches infinity. So what we can do is still combine those two. So you have 6n plus natural log of n over 6n to the nth power. And with that one, it looks like, since we have that n up there, y equals the limit as n approaches infinity of 6n plus natural log of n over 6n. So if we apply natural log to both sides, it gives us natural log of y equals the natural log of the limit. Actually, those continuous. So you can go ahead and switch those two. but probably leave it like that. Limit, and let me move that over a little bit because I'm going to bring my n down since I have the natural log. N times the limit as n approaches infinity of 6n plus natural log of n over 6n. Okay, so we can go ahead and switch those two, which gives us natural log of y equals the limit as n approaches infinity of n natural log of 6n plus natural log of n all over 6n.
Wait, sir.
Yeah.
Couldn't you just do direct comparison test for this? Assume that the 6n plus ln would be an, and the 6n below would be bn. Or actually, no, assume
Yep.
bn top, an bottom, and then just try and solve for if the bottom diverges or whatnot.
You could have mentioned that a couple of minutes ago.
Sorry?
Could have mentioned that a couple of minutes ago. You see me
I
going
just
through
now
all
realized.
this. I mean, really? No, I'm tired, man. All right, so with that one, yeah, makes more sense to use that one. So with that one, let me start on a new sheet of paper.
Yeah, I'm sorry, I'm running out of your paper here.
Oh, we recycle, so you're good. Nope, actually, I need to look at that. So, we use the other test. So we have the limit as n approaches infinity. Okay, they both converge or both diverge. So that would be 6n. Yep, a sub n over b sub n. So that'd be 6n plus natural log of n, and that one actually would still be infinity over infinity, which means we use L'Hopital's rule. Which actually would bring us right back to where we were already. To the nth power. Actually, I think that's why that one wouldn't work, because of that nth power.
Why not? If the top is bn and the bottom is an here.
So really, you just end up
we know
with
that we know by definition 6n plus anything is going to be greater than 6n
bn
alone.
over a sub n to the nth power.
Yeah.
And that's the one thing that's going to throw us off is that nth power.
Couldn't we just include the nth power within the a sub n, b sub n then? So it would be 6n.
Yep, but then you'll end up with some b sub n to the power of infinity. And remember, that's going to be inconclusive. So that's the only reason that, I mean, not inconclusive, but that's not going to be in what they call it, indeterminate form.
Damn.
So it's one of those where it seemed like it should work until you actually get into it, then it won't work.
Sorry, I got your hopes up.
Oh, no problem. I'll just go back to Old Faithful over here. Good thing I only did a little cross mark. All right, so with that one, that gives us natural log of y is equal to, let me see, with this one, the limit as n approaches infinity, and that is n natural log of n. Actually, this should just be infinity times infinity, which is infinity. See if I can simplify that a little bit more before I come to the determination that it's, the conclusion that it'll be infinity. I actually believe this one will be infinity because I don't think it can be simplified. Oh, forgot my natural log. Nope, actually. Nope, the limit I had it right the first time. N approaches infinity. And natural log, yep, that would just be the natural log. Then approaches infinity. Anytime infinity over infinity. Now I know what I can do because that won't work. So instead of n, I'll make that natural log of 6n plus natural log of n over 6n divided by 1 over n, which is still n.
Oh dear.
Oh no, we have n, that just equals 1 over n. Because you multiply both of these by n, it's like that. Okay, so that gives you infinity over infinity, which means you can use L'Hopital's rule now. Does that make sense?
Yes.
Okay. I know that's one of those old tricks that if you get stuck enough, you'll come up with those. Okay, so now we can use L'Hopital's rule since we have infinity over infinity. That's the limit as n approaches infinity.
So we're ignoring the L and Y.
Oh no, we're just not dragging it over.
Okay.
That's all. We'll get that at the very end.
Okay.
Okay, so we have derivative of natural log of 6n. That's going to be u prime over u. So that u prime is going to be really messy looking, but we'll do it anyway. Let's say if u is equal to 6n plus natural log of n over 6n, then u prime, the denominator, by derivative of the numerator.
You're not on the...
Oh, sorry.
Okay, thank you.
Minus numerator times derivative of the denominator, so that's 6n plus natural log of n. Oh, actually should have moved that over. There we go. U prime equals 6n times 6 plus 1 over n minus 6n plus natural log of n. Uh-oh, bring that there. Times 6 all over 6n squared. So that's going to be the limit of the derivative of this is going to be, I'll say, bring my natural log of y over here. That's going to be u prime over u, so it'll be this over that. So this will be 6n. I'll just go ahead and simplify it and make that 36n plus 6 minus 36n minus 6 natural log of n. Let me separate that. Divided by 36n squared, where these two cancel each other out. So we have a natural log of y is equal to the limit as n approaches infinity of 6 negative 6. We can actually factor out negative 6. When we factor out that negative 6, it'll cancel with that one. So we'll end up with negative 6, 1, or negative 1, plus natural log of n over 36n squared. So our natural log of y, once these two kind of cancel out, is going to equal the limit as n approaches infinity, natural log of n minus 1 over 6n squared. Just a little less upsetting looking. Okay, so here we still end up with infinity over infinity, so we apply L'Hopital's rule again. So we have natural log of y equals the limit as n approaches infinity of 1 over n, that becomes 0, over 12n, okay, which gives us Yep, 0 over infinity. So as this number gets closer and closer to 0, this number gets bigger and bigger and bigger. So we end up with natural log of y is equal to 0, which isn't our answer yet because we have to raise both sides to e. So e, natural log of y, equal e to the 0. Are you serious? Y equals 1. All that, I hate when you go through all that work and end up with 1. That burns me up. It just seems like a waste of effort. Okay, so y equals 1. So with the, which test did I use again?
Divergence.
Divergence. So if it, yep, which is not equal 0. After all that, I forgot what test I used. So it's not equal 0, so it's divergent.
Little problem like that, the other test.
Nah. Like I said, the original problem was just, is it absolutely convergent, divergent, or inconclusive? It was just multiple choice. So, just so happens somebody wanted to see how it was worked out.
Oh, sorry.
Yeah, but that's how it would be worked for this particular one.
I've had teachers before where I asked a question like that, and they refused because they didn't know how to solve it. So, I appreciate it.
Most you can do is just jump in and try it.
Right.
If you get stuck, you get stuck.
Right.
It won't be the first time, it won't be the last.
Exactly.
So, all right. Any other questions on this one? Yes.
So the limit of 1 over n
Mm-hmm.
is infinity. For what n?
Well, the limit is actually 0. Because remember, you're just approaching the limit of 1 over n. It's getting closer and closer to 0 as n gets bigger and bigger and bigger.
I'm saying for the first.
Hopefully 0 to the 0.
Oh.
When you did the 1 over 1 over,
Because wouldn't that be
You plugged
1
in
over
the-
0? For 1.
Oh, no, because this one's getting closer and closer to 0. So when you get a number that's getting smaller and smaller and smaller, this number here is just getting bigger and bigger and bigger. Yeah.
I see it now.
All right. Does that make sense?
Yeah,
No.
I was looking at it. Okay.
Oh, no problem. All right. Any other questions?
Isn't 0 over 0 indeterminate form?
Mm-hmm.
Then how can we say that the ln of y equals 0?
What do you mean ln of y equals 0?
If we're doing
For
that
this
limit
one?
there, for
Or-
yeah, if you go back up to the limit of 1 over n,
Mhm.
12n,
Mm-hmm.
that should approximate to 0 over 0. No, wait, no, 0.
Yeah.
I mean,
Yeah,
okay,
well,
never
yeah,
mind.
got it.
Yeah.
Okay. Yes.
I got one more test.
Sure.
So to find, for the convergence test, to find a number that converges, you couldn't specify, you couldn't, like, if you use the convergence test and you found a
Mhm.
number, could you
Mhm.
say that that number is the number that the series converges to, or do you have to use?
Well, you'd have to find a number or a series less than this that also diverges. So if a series less than this diverges, so if a series, let's say, less than that and it diverges to infinity, then the one, or a sub n, if it's always less than that, then that would diverge, always greater than that, it would diverge also. The
Okay.
only problem is, I couldn't really off the top of my head think of
so the other.
a value that was less than something that messy looking. So if it was more of a simple looking series, it wouldn't be a big deal. But by that one being kind of messy looking, it kind of made it hard to pick one. All right. Any other questions? All right. If there are no more questions, make sure you sign in sheet right up on the front desk. And I'll see you on Monday.
Wednesday, or, Wednesday, right?
I think Monday, Wednesday.
Nope, Monday.
Monday.
Yeah.
Yep.
The second. I meant to say, I misspoke when I said Wednesday, but.
Oh,
Monday
okay.
is the-
I was about to say,
Right?
yep, Monday.
That is 4 p.m.